And I'm live. That is cool. Today is 27th of August 2025, Wednesday, and we will continue our dynamic programming thing that we were doing yesterday in or on CP Algorithms, which is a cool website. CP Algorithms, not creepypasta. Yep. Go to navigation and then we have dynamic programming, and yesterday we were doing knapsack. So that is cool. Knapsack. And after knapsack, we will have this longest increasing subsequence. That is one thing. And also, we already know about this book, Competitive Programmer's Handbook, written by Antti Laaksonen. I think I pronounced it correctly. But then there is also this book, written by the same person, but this is more comprehensive. This is the third edition. This one was written in 2018, and this one came out in 2024, if I am correct. And I think I am. Third edition, 2024. Yep, cool. So this one is also latest and more comprehensive. That is cool. So yeah, just wanted to point that out. This one is named Guide to Competitive Programming. That is cool. And there are stuff here, of course, and knapsack problems. We have already gone through the dynamic programming section of this book. This part, dynamic programming section. Let's go through the dynamic programming section in this book. And there are also references at the end, which is cool. And we will read a bit of dynamic programming from this and about knapsack. Knapsack, yesterday we did zero knapsack. It was not that difficult. I mean, we were able to implement zero knapsack, but then there is complete knapsack, which we do understand a bit, but we do not know why this thing specifically works. Like how we can convert this formula into this and why converting this thing into this thing works. Right? Because this thing reduces the time complexity immensely, which is pretty good. You do not want time complexity n square into w, and w is generally very big, and n is around at max around 100. So 100 into 100, 10 power 4, and w can be 10 power 9 even, which is very bad. A total 10 power 14, which is you do not want a time complexity of 10 power 14. And then there is multiple knapsack, which we have no idea about. Then there is implementation for that. Then there is monotone queue optimization, something. Then mixed knapsack. There are just a lot of variations in knapsack, it seems. Yep. So we will read about dynamic programming from this new comprehensive book. We will solve a few CSES questions. Yesterday we did solve a few questions. Yep, yesterday we solved this many questions. And yep, today maybe we will solve a few more. Edit distance, we have written a question on edit distance. Longest common subsequence is crazy, is like actually crazy. There is a thing in CLRS, Introduction to Algorithms. In this book, in the dynamic programming section, yep, dynamic programming, there is this longest common subsequence. Longest common subsequence. And this is actually cool. You can write a program on longest common subsequence and apply it on DNA and find longest common subsequence between two DNAs, and you would know you are the father or not. That is crazy. So yeah, let's go to this thing. Dynamic programming, page number 69, of course. Okay, yep, here we are, dynamic programming. And now, dynamic programming is an algorithm design technique that can be used to find optimal solutions to problems and to count the number of solutions. Okay, It is a algorithm design technique, a technique which we use to design an algorithm and to find optimal solutions. Solutions where we are minimizing or maximizing some values, or to find the number of solutions. Solutions which might be or might not be optimal. And in some questions, the optimal solution, there is not a single optimal solution. There are a lot of optimal solutions with whichever value you are trying to optimize. It is if you are trying to minimize some value, then there are a number of solutions which have that same minimum value, but they get to that value through some different means. So in those questions, you can give any optimal solution, and that is cool. Or you can count the number of solutions. And a solution is considered a solution if it satisfies whatever the given conditions are, whatever the given matrix are. In this chapter is an introduction to dynamic programming, and the technique will be used many times later in the book when designing algorithms. We are not learning, we are designing algorithms. That is crazy. Okay. And a little bit of water would be really cool. Section 6.1 discusses the basic elements of dynamic programming. And in the context of a coin change problem, in this problem, we are given a set of coin values, and our task is to construct a sum of money using a few coins as possible. There is a simple greedy algorithm for the problem, but we will see it does not always produce an optimal solution. However, using dynamic programming, we can create an efficient algorithm that always finds an optimal solution. And this, I think, is very important, getting to know the very basics. Why do we even need dynamic programming, or what is dynamic programming? If we can nail that down, then we are going to be very well off. We can just point to something and say this is what dynamic programming is, not just memorizing a line or two and saying this is tabulation, recursion, iteration, or this or that. And why we need dynamic programming is pretty cool. And also, I think repetition is also pretty cool. If there is this coin change problem, which I have solved at this point quite a few times, and if I were to solve it a few more times, I would be able to see some meta patterns, I could say, in this, which I can generalize, or you can generalize after solving the same problem a couple of times or multiple times, maybe 4, 5, 6 times. And you would be able to see some general patterns which you can apply generally in any question, which is really cool. You can nail down the basics which are characteristics of dynamic programming. Section 6.2 presents a section of problems that show some of the possibilities of dynamic programming. The problems include determining the longest increasing subsequence in an array, finding an optimal path in two-dimensional grid, and generating all possible weights, sum in a knapsack problem. Okay, after we have solved a few dynamic programming questions, we would be able to determine if a thing uses dynamic programming, because when we know that a question a question can be solved using dynamic programming, then it becomes like half as hard, and then figuring out which things you need to store in your state at some point through the iteration or recursion. That is the other challenge. But just knowing that this current problem can be solved using dynamic programming is pretty good. It's pretty important. And now, basic concepts. In this section, we go through the basic concepts of dynamic programming in the context of a coin change problem. First, we present a greedy algorithm for the problem, which does not always produce an optimal solution. After this, we show how the problem can be efficiently solved using dynamic programming. Yep, greedy algorithm works sometimes, but not every time, and dynamic programming works every time. 6.1, Point 1. Suppose that we are given a set of coins from 1, C1, C2, Ck, and a target sum n, and we are asked to construct the sum n using as few coins as possible. There are no restrictions on how many times we can use each coin value. For example, coins if are 1, 2, and 5, and our target sum is 12, we can use 5 plus 5 plus 12, 5 plus 5 plus 2, which is 12. Yep, 5 plus 5 plus 2, which is 12, which requires 3 coins, and that is most optimal. You cannot get to the sum of 12 using any fewer coins than this. There is a natural greedy algorithm for solving the problem. Always select largest possible coin so that the sum of coin values does not exceed the target sum. Just take the biggest denomination of the coins that you have and try to get to the target. For example, if n equals 12, we first select 2 coins of value 5 and then 1 coin of value 2, which completes the solution. This looks like a reasonable strategy, but is it always optimal? And I think we should define what optimal means. And it would be really good if we can go to ChatGPT and ask what optimal means. So we are trying to create a skeleton through which we can look at dynamic programming and say, this is dynamic programming. Let's say we have this dynamic programming. And what is this? I don't know where, but somewhere I heard that dynamic programming is a mathematical framework for coming up with solutions, which is very similar to what we read here, that dynamic programming is an algorithm design technique, a framework through which you can design algorithm, not an algorithm itself. Something like, it is not like Dijkstra's algorithm or Floyd-Warshall algorithm. It is an algorithm design technique, not an algorithm itself. And what we have been able to read till now, it says that we need optimal. It has something to do with optimal solution and with number of solutions. Go to ChatGPT and ask what is an optimal solution. And I heard Don Knuth, the guy who is a legend at this point in computer science. He said that when he was very young, when dynamic programming was a new thing, he said optimal solution meant a solution which is optimistic, which is like a happy solution, a solution with which you would be happy. That is one definition for optimal solution, a very old definition, early definition. Now let's ask ChatGPT, what does an optimal solution mean specifically? Good question. Optimal solution is one of the terms that gets thrown around so much. It sounds obvious, but it has a very precise technical meaning depending on the context. Let's break it down. General idea. An optimal solution is simply the best possible solution to a problem according to some criteria. The best possible solution, that is the general idea. The best possible solution to some problem according to some given criteria. That makes sense. If, for example, you are buying a house and your criteria is to find the cheapest house, then finding a house which only costs maybe a few $1,000 would, but is very bad in conditions, does not have a kitchen or anything, but is only a single room, then that would be an optimal solution, because finding cheapness, just the cost of the house was your only criteria. But if you have multiple criterias, for example, you want the cheapest house, but you also want there to be a kitchen, to be a nice bathroom, and other stuff, then it is more complicated. And finding the optimal solution is a bit hard. Now, not just a solution that works, but the one that is better or equal to all the others in terms of what we are trying to optimize. Yep, optimal is not equal to perfect. It just means cannot be improved upon within the rules we have set. That is one of the best definitions I have ever heard. It means cannot be improved upon within the rules we set. You cannot find a better solution than this. That is an optimal solution. There we go. That is pretty cool. Now, mathematical optimization context. This is the general idea. A solution which cannot be improved upon within the rules we have set. So we have some set rules, some you could say even a game, and within that set of rules, a solution that we have come up with cannot be made better than what it already is. That is an optimal solution. Now, optimization context in mathematical context. Suppose you are solving an optimization problem like minimize cost or maximize profit or minimize time, etc. Objective function, the thing you want to optimize, example cost, objective function, okay, that is mathematical talk, constraints, the rules your solution must obey, example budget, resources, equations. Okay, an optim an optimal solution is any feasible solution satisfies constraints for which the objective function reaches its minimum or maximum values. So, okay, what I am understanding from this is that you have a function, objective function, which takes in some parameters, and those parameters have some certain constraints in the range of values that they can take. And when you graph that function on a Desmos, then an optimal solution would be a solution where those constraints, those parameters, when given to the function, give its maximum, its minimum, or its maximum possible value given those constraints. That makes sense. Shortest path in a graph optimal solution is the path with minimum length. So in this, when we are finding the shortest path, our objective function could take in a number of nodes and then return the path. And what are the constraints? The constraints might be you cannot go to the single node twice. That is just repeating and not necessary. It is not a constraint, but it is better to avoid. Constraints would be you can only give the nodes which are in your graph. You cannot give nodes which are outside your graph or nodes which are not reachable. You can only give nodes which are in the same component. A component is a subset of nodes in a certain graph in which you can go to any other node starting from any node. And yeah, a graph can be divided into different components. Scheduling workers. Optimal solution minimizes total cost while covering all shifts. Yep, optimal solution. That makes sense. Cannot be improved further upon within the rules we have set. That is one of the best definitions I have heard. And there is the concept of objective function seems also important. Now, computer science algorithms, this is our territory. In algorithmic problems, an optimal solution is the one with the best outcome possible for the given problem definition, with the best outcome possible. That is the same thing, cannot be improved upon within the rules we have set. And now the examples for an optimal solution that is the best outcome possible are traveling salesman problem, TSP, which is NP-hard. Optimal solution is the shortest possible tour visiting every city once. Okay, this is NP-hard, right? And this is NP-hard, that is, we do not have a constant or we do not have a polynomial time algorithm which can solve this problem. So that is why we call this thing NP-hard. And knapsack, I think, is also NP-hard. And this might be very obvious, but I just noticed that even though these problems are NP hard, we do not have some algorithm to solve these problems. Still, there is going to be some optimal solution for these, which which sounds very obvious, but shit, I never thought about this. That is crazy. Even though the problems are NP hard, that is no polynomial time algorithm has been found to solve these. There are still going to be optimal solutions for them, and we can check this and we can check this if there are optimal solutions for this by a complete search through the solutions by a complete search through the solutions set, through the total set of solutions, which is cool. Okay, this should be very obvious. This should have been very obvious. This is the first time that I noticed this, that even though these problems are NP hard, there are optimal solutions. Of course, there are optimal solutions. These are optimization problems. Shit, that is cool. And yo, that is even cooler. Competitive programming context. When you submit a solution, a correct solution gives the right answer for all test cases. Okay, an optimal solution, algorithm solution, not only gives the right answer but also does so within time and memory limits. Okay, you are talking about now optimal solution in the sense of competitive programming. That makes sense. That makes sense. So optimal often gets has a dual meaning here. The output is the best possible answer to the problem, and the algorithm runs in the best practical time and space complexity. Yep, that is dual meaning. Yep, you are right. And beyond doesn't mean no optimal solution exists. It only says we don't currently know a polynomial time algorithm that finds that optimal solution for every instance. Your summary is solid for NP-hard optimization problems like TSP or knapsack, traveling salesman problem, or knapsack. There are optimal solutions, and an exhaustive, complete search over all feasible solutions will find them, but usually at exponential cost. I will lay out the precise facts, the important caveats, and the common practical workarounds, which we do not have to get into. We can go through the TLDR. Yes, NP-hard problems do have optimal solutions, and brute force complete search will find them. The problem is efficiency. Complete search usually takes exponential time, so we use smarter, exact algorithms, DP, branch and bound, ILP, dynamic program, branch and bound. I don't know. ILP is in linear programming. I don't know. Linear programming, or maybe, or approximation schemes and heuristics. Providing a candidate is optimal. A candidate is optimal is typically as hard as finding it unless you can produce a match lower bound certificate. That is cool. And we hard held car. Yep, Richard Carr. And now moving back to the book. Basic concept, why greedy fails, and we are looking for some optimal value. There is a natural greedy algorithm for solving the problem. Always select the largest possible coin so that the sum of coin values does not exceed the target sum. For example, if n equals 12, we first select two 5-value coins. Now what remains is 2, and then we choose a coin with a value 2, which completes the solution. This looks like a reasonable strategy, but is it always optimal? No, it is not always optimal. It turns out that this strategy does not always work. For example, if coins equals 1, 3, and 6, and our target is 6, 1, 3, and 4 are the coins, and our target is 6, then a greedy approach would first choose 4, and then to complete the target of 2, it would choose 2 coins of value 1, giving us a total of 6. But that took 3 coins to get to 6. We could have instead chosen through 2 coins of value 3, which is better, which is just 2 coins to get up to 6. But the greedy strategy produces a solution with 3 coins. This simple counterexample shows that the greedy algorithm is not correct. It is interesting. It is an interesting question. When exactly does the greedy algorithm works? Pearson 1 describes an efficient algorithm for testing this. That is cool. Pearson. What is Pearson? Okay, shit, this thing. Pearson. A polynomial time algorithm for change making problem. That is cool. A paper written in 2005. Now, here, how could we solve the problem then? Of course, we could try to find another greedy algorithm, and yes, what does it mean to find another greedy algorithm? Greedy algorithm is a category of algorithms which make the optimal choice at some moment, and hopefully at the end making most optimal choices locally would result in a solution that returns the most optimal solution globally. So in greedy algos, we have local optimal choices result in global optimal solution. Just this is just the category of algorithms in which making the local optimal choices, the solution that we get after making local optimal choices is globally optimal. So that is just a category of algorithms called greedy. Now, how could we solve it then? However, using dynamic programming, we can create an algorithm that is almost like a brute force algorithm, but it is also efficient. Thus, we can both be sure that the algorithm is correct and use it for processing large inputs. Furthermore, we can use the same technique for solving a large number of other problems. It is like a brute force, but is also efficient, finding an optimal solution. Yep. To use dynamic programming, we should formulate the problem recursively so that the solution to the problem can be calculated from solutions to smaller subproblems. Solution to a given big problem could be calculated by having solution to a bigger problem. That is, if I have some bigger problem like this is very big problem. How do I solve this? I can break this thing into two. How do I break this thing into two? Like literally copy, paste, and let's say now it is broken. Break this thing into two. And I am saying that to get the solution for this thing, I need to find the best solution for this and the best solution for this. And the type of problem that this is the same type of problem that this is, which is the same as this problem. And we can further divide these into even smaller subproblems. And eventually we will reach some base case for which we have already settled the answer, and then a backup call stack would start, and eventually we will reach back to this state and we will find the solution for this state. And I would like to demonstrate something here, the same thing here. 2023, there was this problem that I was unable to solve. And I don't know if I will be able to solve this now if I tried. This is advent of code, and we can solve this problem. I think, okay, we will solve this problem after we have gone through the 6.1 section of this whole thing. Let's go. And we will finish this whole chapter today. Finding an optimal solution. To use dynamic programming, we formulate the problem recursively. We formulate the problem recursively. We break up the problem and write it recursively. Formulate is we write it recursively. We propose the problem in sense of recursion, so that the solution to the problem can be calculated from solutions to smaller subproblems. The recursive structure that the problem is going to have is going to depend on optimal solutions to smaller subproblems. In the coin problem, a natural recursive problem is to calculate the values of a function. Solve x. What is the minimum number of coins required to form a sum x, right? Clearly, we could put our target value x equal to something 12 in our example, and solve 12 would give the answer for that. Clearly, the values of the function depend on the values of the coins. If the coins are this, then solve would have these values. And my theory is that we had some problem. My theory is this, that we had some problem, like the coin change problem, NGE. We had the coin change problem, and we theorized that since the possible number of coins, choices for coins is limited, 1, 2, and 5, to get to this sum, for example, let's say we want to get to 12. To get to 12, there are only a certain choices that I could have taken to get to 12. I could have chosen 1 as my last coin, in which case I would have gotten to 12 from 11. I could have chosen 2 as my last coin, in which case I would have gotten to 12 from 10. I could have chosen 5 as my last coin, in which case I would have gotten to 12 through 7. And now, what do I do? I can say, well, I need to find the answer for these 3 subproblems. If I know what is the minimum number of coins required to get to 7, let's say it is A, and if I know the minimum number of coins required to get to 10, let's say it is B, and the minimum number of coins required to get to 11, let's say it is C. And to get to 12, the answer, if we are saying Fn returns the minimum number of coins, then Fn would be equal to minimum of Fn minus 1 comma Fn minus 2, that is another coin that we could have chosen, and minimum of Fn minus 5. Those are the only possible choices we could have made. Find the minimum, and whatever is the number of coins to get to 11, to get to 10, or to get to 7, add 1 to it, because at the end, after getting to this number or to this number or to this number, we made another choice, either 1, 2, or 5, to get to 12. So that is why we have to add one more here. That is the general solution for this problem. And I would like to make a whole chart for this, which is cool. So let's say we start with 12. For 12, we could have either gotten through 11 using 1 as our coin. We could have gotten by 10 or by 7. And for 10, we could have chosen 2, and then there was the choice of choosing 5. Now let's start solving for 11. When solving for 11, we could have chosen 1 as our coin. We could have chosen, when we chose 1 as our coin, we would like to find the solution for 10. When we had chosen 2 as our coin, we would like to find the solution for 9. And when we have 5 as our last coin, we would like to find the solution for 6. So here we chose 1 as our coin, here we chose 2 as our coin, and here we chose 5 as our coin. And since this thing is the same as this thing, we can say we can just ignore this for right now and start writing the subsequent tree for this one. So let's first complete this one. To get to 9, if I chose 1 as my last coin, I would have been at 8. If I chose 2 as my last coin, I would have been at 7. And if I chose 5 as my last coin, I would have been at 4. And we have 7 here. We also have 7 here. So let's say for our convenience, for not wanting to write this whole tree down, we will not continue on this 7 branch, and we will write the entire solution on this side for 7. And we have done the same for 10. Now, if we expand this 8, before we could have chosen 1 as our last coin, and this will keep on going forever. Like we would go to 7, then we would go to 6, then to 5, then to 4, because in this left direction, we are always choosing 1 as our coin. So we could directly write here that the answer for this branch, not the answer for this branch, but the answer for this thing would be around 8, or exactly 8, if we were to go down that path, because we are only choosing 1 as our coin always. So we should not pursue that line. We can start with choosing 2, and with choosing 5. When we chose 2, 6 would be our remaining thing, 2, and here we chose 5. And now we can go further. We will not choose 1. If we chose 2, then we were at 4. If we chose 2 again, we would be at 2. And if we chose 2 again, we would be at 0. So there is something. So answer for this would be 1, because we only have to choose 1 coin of value 2. And answer for this would be 2, because we do not have any other choice. And we could choose 1, but that is, as we have already established, not really good. So 2 for this. And on the other side of 6, we could have chosen 5. If we did choose 5, then 1 would be remaining, and then we could have chosen 1 as our last coin. We would here get 2. Yep, we would here get 2 to get to this, not here. Here would be 1. So for 6, the most optimal choice is 2. And for 3, the most optimal choice is also 2. Therefore, for 8, the most optimal choice would be 3. 2 plus 1, 3. The most optimal choice for 8. And we will write the most optimal choice for 7 there on this side. But for 4, we already know the most optimal choice, which is 2. So we can write here 2. And for 6, we already know the most optimal choice. It is 2. We can write 2 here. And for 10 and 7, we will continue here. We will not go down, we do not actually have to go down the path of choosing 1 or choosing 2, because we already know here, just by looking at this, that we can choose two coins of value 5. 5 plus 5 is 10. So 10, 2 would be the answer for getting to a value of 10 and getting to a value of 7. 2 would again be an answer choosing a value, a coin of value 5 and a coin of value 2, we could get to 7. So 2 is also the answer here. So we could say 2 is the answer here. Therefore, for 9, answer would be 3. I could go through any of these paths and then I would have to choose another coin. And for 10, we know the answer is 2. So among these, 2 is the minimum. So the answer for getting here at 11 would be 3. So 3 is here. 3 is what we have here. 2 is what we have here. And 2 is what we have here. And the minimum is 2. So the answer would be 3, which is cool. 3 is the answer, which is actually the answer. That is cool. Now moving on, reading more of this thing. The essential property of solve is that its values can be recursively calculated from its smaller values. Makes sense in the same way that we have written here. Here we are representing the solve function by f of x, f of n or x, any number. It would be equal to the minimum of any coin denomination subtracted from n plus 1. That would be the answer for fn. And for base cases, answer would be 1. When n equals 1, answer would be 1. When n equals 2, answer would be 2. Answer would be 1. When n equals 5, answer would be 1. Those are the base cases. And for negative coins, we do not have any solution. It is infinite. The idea is to focus on the first coin that we choose for the sum. For example, in the above scenario, the first coin can be either 1, 3, or 4, in which scenario, in this scenario, 1, 3, or 4. If we first choose coin 1, the remaining task is to form the sum 9. Yep, for f of 10, using the minimum number of coins, which is a subproblem of the original problem. Of course, the same applies to coins 3 and 4. Thus, we can use the following recursive formula to calculate the minimum number of coins. We can use this recursive formula to calculate the minimum number of coins. And this to me feels very, very redundant. Like literally, really redundant. You took part in yesterday's contest on code forces. To be honest, yesterday in code forces, when I saw the questions, where is code forces? In yesterday's contest, yep, my rating is very low right now. It got reduced by a high amount. In yesterday's contest, I was able to solve 3 questions, but that was after the contest. During the contest, I saw the questions and I was just unable to come up with anything. But then after the contest, I was able to solve 3 questions, which is very bad. My rating would have increased quite a bit if I did this during the contest. So that is bad. But the thing is, now I know a few things. In this first question, the important thing was that the concept that was used here, this thing about range, that the range can be in this range. You can choose any x or any y in this range from 1 to n minus a plus 1. This is a sliding window concept which I was unfamiliar with, so I was unable to come up with a solution during the contest, which is bad. But now I know, so that is cool. So now I know a few more things, which is cool. And this one was actually very easy. This one was not very hard. I got this right, yep, but not during the contest. This uses maths and, to be specific, modular arithmetics. And the solution for this is actually pretty easy, to be honest. And what I did is Yep. Because our goal is to make the GCD greater than 1. Our goal is to make the GCD, which is like this, GCD greater than 1. So let's say GCD, we are trying to make the GCD equal to 3, right? So every number that is there in the array can be represented in this modular arithmetic sense on this wheel. And let's say your k equals 4, or if your k equals, okay, this is not a good example. We will go with a generic example. If the k that is given in the problem is some number, which it is, if you have k which you can add to the AI numbers, and your goal is to find GCD greater than equal to 1, which means there is going to be some number, let's call it x, that divides every number AI after you have added k in some quantity to this AI. And what this means is that in this arithmetic modular wheel, at the start, every number is going to be at some position in this arithmetic mathematics, in this modular arithmetic wheel, dot dot dot, till x minus 1. Every number is going to be here. And let's say initially all these AI numbers are scattered. One AI is here, another number AI is here, another number AI is here. And what you are doing is you are adding k to this number, and that is going to change the position of this AI to some place. And your target is to get all of these numbers to come up to 0. If you can do that, then you have a GCD greater than 1. So what we need to find is this number x. And what can be this number x? For this number x, the thing that you need is that no matter where this AI number is on the wheel, you need the ability to get this number to 0. This number could be anywhere on the wheel. All you want is for this number to get to 0. For that, you need minute control on the amount that this number will move on this wheel when you add k to this number once. So what you need is k to have k to be either at this place, on the wheel, or at this place x minus 1 on the wheel. Why? Because if you have x here, then by adding k a certain number of times, any number of times, you are moving this number once along the wheel, and at the end you will get it here, which is cool. But if you have x k here on the wheel, then adding k to some number will move it back one step, and the same process in reverse, you can get any number to 0, which is cool. So this x, and since k is less than equal to 1, it can be 1. So you need this x, you need your k to have n modulo equals either 1 or n minus 1. If you want 1, then you would like, not k, this is reversed, k modulo n should be equal to 1 or n minus 1. And to make modulo equal to 1, you would make n equals k minus 1, but that is bad because you can also have k equals to 1, and in that case n would be equal to 0, which is not acceptable. Therefore you would like to have k modulo n equal to n minus 1, which would be when n equals k plus 1. if n equals k plus 1 and you are taking modulo with n of k, you would get a remainder of n minus 1, which is exactly k, which is cool. So your x equals n minus 1, not n minus 1, your x equals k minus 1, and you see the position that this AI number is on this field, and whatever the remainder is, you add ki to this number that many times, because adding k to this AI number moves this number back one step. So if this number is on the fourth position, you would like to add k to this number 4 times, and adding k 4 times would bring this number down to 0, and that is cool. That is what I did here. Taking the input like n and the array a, initialize x is going to represent the ai'th number, and output x plus x remainder with x modulus with k plus I, k plus 1. K plus 1 is this x number, and whatever that value is, multiply it by k and add it to x, and that is your answer. That is cool. And the next one was also a bit more complicated than that one, but still this was fine. This was fine. I would have done this. I don't know, I just didn't give it any effort. I also did, I took a lot of time. In second one, I was overthinking. I knew I can make every number I multiply of k1, k plus 1, but I was thinking maybe I will do more than k operations. Yep, I submitted first and third in 45 minutes, submitted second, one in the last 2 minutes. That is crazy shit. Okay, first one is of parity. Yep. Right, we need some same parity between all three numbers, and if b is greater than a, then we don't need to check parity of a. Yes, yes, that is exactly the same thing. I don't know, I was just unable to come up with that during the competition somehow, which is crazy. Now, I would like to do some CSES questions on dynamic programming. There has been a lot of yapping. CSES is good. CSES, maybe not array description, I don't know. Yeah, let's go. Array description. I've not done this one. That is cool. We can do that. And yep, I am in the middle, which is cool. And in third one, we needed to get the sum of both adjacent elements at even index if the sum is greater than at even index. Yep, when you are at a even index, then escalate draw, escalate draw. Whenever, let's say you have three elements and let's call this one even, then you want whatever is the value of this one, you want this and this. If this number is greater than this number, then you want to cut this whole higher part off, and whatever this value is, add that to your response, to your answer, and then do the same. If this one is greater, then shove this whole part off, and then check if their sum, this thing plus this thing, is greater than this thing, then whatever is the thing, remove that part from this and add that to your answer, and you will have a working answer. And now CSES, a bit of CSES would be pretty nice. CSES, dynamic programming, and also add-on of code. Add-on of code is actually one of the best things out there. And let's do add-on of code before CSES, which is cool. And okay, good. branch 2023 and get checkout 2023 CD. This is supposedly, I guess, day 11. This is day 12 actually. Shit, I don't have a directory named day 12, which is messed up. And yep, part 1 dot cpp competitive. Yep. And I think I wrote a function which gets the input. I think I wrote a function which gets the input from the online place, because input is something like this. I have to run my function on something like this. And I think if I remember correctly that I wrote a function that can get the input. And it was get log get branch. I have only a couple of branches. Get 2019. Uh, mm, get data.js. No. Shit, I guess. Shit. But okay, I will have to write the function here again. Get data.cpp. And how do I make a simple call on the web to get some data? How to make a HTTP call request in C++. 16 years old. Shit. Libcurl, import this thing. Then response CPR. What is CPR, by the way? Making an HTTP request in C++ is typically achieved using a library that handles the underlying complexities of secure communication, SSTLS. Okay, this is HTTPS. Okay, SSL TLS with raw sockets can be useful for HTTP. HTTPS requires handling certificates and all that, all those things. Recommended libraries are Libcurl, include the necessary header, which is this CPR. Do I have this? CPR doesn't seem like I have this. How do I get this thing? Make the get request. Okay, how do I, first of all, I will have to download Libcurl. Or is that how I download Libcurl? And SSL. Okay, it is running. It is running. No available formula with this. Okay. Do install SSL. Okay, no available. Open SSL. Do install open SSL. Okay. Okay, it is already there. It seems to be already there. So I should have the thing. Reddit client HTTPS lib get HTTP lib, that is something, get data HTTP doesn't seem to be there. Socket is, I can use socket if I want. That is very low level and I don't know about that. Raw sockets versus libcurl. Libcurl and C++. Libcurl programming tutorial. That is crazy. Curl config. Okay. Mhm. This document attempts to describe the general idea, more detailed building. How do I build? How to enable this flag, it seems. C flags. Okay. Your compiler needs to know where the libcurl headers are located. Therefore, you must set your compiler's include path to point to the directory where you installed them. The config3 tool can be used to get this information. Curl config C flag. Yep, empty curl config is there. Curl config v. Yep, build shared says yes. If libcurl was build shared cc, it just says cc. Preprocessor version, check for configure given arguments to building curl. Libs. Yep, lcurl. Okay, lcurl. Okay, so I want this to go to my LSP, which is clang D, and I think I can just say here include lcurl. I don't know if that is correct. Lcurl. I think that should be correct. If I run my LSP again, get data LSP info. It is flag D is running, and okay, is the flag here? Command is this background index, and log size is somehow massive, 94 MBs of log size, crazy log size, and current base ISO. I don't know. Uh, conflict. Okay, linked programs. Libworld. When having compiled the program, you need to link your object files to create a single executable. Okay, shit. Okay, that is bad. So I need something like this. C flags. What are the flags? Version, num, output the number of information as a number, static lib line linked information, SSL backend prefix, libs, help, display this help and exit. Cur config, help, please help. CA bundle install path, build share. Yes, if libcurl was build shared C flags, it just does not say anything. Where are the compiler flags? How do I know? Curl global init. And this function is going to give me error. My LSP doesn't know it. Maybe I have to restart my LSP. Okay, is it running? It it, it is. Okay, shit. That is not the LSP that I want to be running. Shit. Now it is the Apple version of Clang D that is running somehow. Now it is cool. Now it is homebrew. Homebrew is cool. Shit. Curl is not there. My this thing does not know about curl. You install curl. Let's go. Yo, shit, that is a lot. Yep, bro, can you tell me where can I study these topics, DPDSA trees and all? Where are you studying from? I am studying from a few different things. This is just CSES. I came to know about this book yesterday, and yep, this is now going to be one of the resources that I will be using. And then there is, of course, this book. This is like everything you want is here in a very comprehensive way with examples and mathematics, everything. That is why this is 1600 pages long. And then there is this competitive programmers handbook. And then there are also some YouTube channels. And then there is CP algorithms. You can go to CP algorithms, go to the navigation and see algebra fundamentals, prime numbers, sieve of Eratosthenes, everything. Modular arithmetic. This is something I should read. Modular arithmetic. Okay, modular arithmetic. Cool. That is what you can do. What is today's plan for the stream? Yep, going through knapsack and dynamic programming. That was the original plan. But I think I will be going through some CSES dynamic programming problems instead. And one advent of code problem, which I was unable to do last year. Last year, 2023. This uses some dynamic programming thing. And right now, what we are trying to do is, since the input for questions on advent of code are given to me like this, I have to go to the problem statement and click here, get your puzzle input, and go to that tab, copy and paste. I do not want to copy and paste. What I want is to have a function to which I would say I want the input for this year and this day, give me the input. And that function internally has to go to this URL and do some fetching and get this thing and return this to the caller as a string. That is what we are trying to do here using Libcurl. So this is some development stuff, you could say. CP4 book? What is CP? No, any CP parser for no. CP parser? How would you have CP parser? What do you mean by CP parsers? Specifically for CP, what would a CP parser mean? You are solving CP in C++. You have a C++ LSP called ClangD. And why would you need a parser? Specifically a parser. And even that for CP. That okay, maybe I'm not understanding the question correctly. CP parser. That is crazy. C flags. This does not work. This somehow just does not work. Ah, well, config C flags. Shit. Okay, that is an invalid option. This just does not return anything. Uh, flags to compile. Wait, maybe, just maybe, it is my LSP that is giving me the error. Wait, maybe I have not done this thing correctly. L curl, that is for linking. Yep, this is not include. I have, that is easy, that is easy, that is easy. How do I know where the curl library is stored? It is in homebrew. cd slash cd opt brew homebrew ls, and I think inside seller curl 8 version 8, and there is an include curl, and there are the header files curl.h. Yep, yep, this software is licensed as described in the file copying. Yep. You should have received as a copy of this distribution, as a part of this distribution. The terms also are available there. You may opt to use copy, modify, merge, publish, distribute, and or sell. Why was I so stupid? I should have known that that is how you add stuff. Okay, so what we need to do now is tell our LSP that this is something that we want to add to our files that we are changing. So add this slash opt slash home brew seller and curl, and I don't know the next thing. Open a new terminal, opt homebrew seller and curl, and version is 8.15.0, 8.15.0, and then include, yeah, that should be it. That should be about it, I guess. Go to AOC, enter get data, and if I now include, we do have curl.h, which is amazing. Okay, it is working. And also, yeah, when I'm compiling, I can just use the compiler flag to link, to compile and link. Cool. Right. This folder only has the include files. Curl.h. This folder only has the include files, but not and include files only include the function declarations and not the definitions. So after compiling, at the time of linking, I need the definitions, which is going to be helped by this thing. Linking process. For compiling, I just need this thing, and for linking, I would need this thing. That is cool. Now, how do we get something done? Curl global init. I do not need to get into all of that. I just need to know how to get some data. Okay, I'm going to make some gamble. And okay, we create some handle using this function, curl easy init handle, and then we call this function with a handle with curl opt URL, and then another URL. What is opt URL description? Pass in a pointer to the URL to work with. The parameters should be a char pointer to a null terminated string, which must be a encoded URL. Some example would be nice, or some example for this thing would be nice. Okay, examples don't seem to be there. Curl easy setup. Okay, let's do this thing first. not main. This will return a string, a standard string, and it will be called get data. And this function is going to take in integer for day and an integer for year. And what we need is auto handle equals curl. Okay, curl easy setup, curl easy in. Okay, that does not give any error, which is cool. Okay, I guess I should actually read some of this stuff. Portable code in a portable world. Like it would parse the input from the URL. Okay, plugin for testing stuff, competitive programming helper, CPH extension by Divyanshu Agarwal. This tool is for VS Code. I am asking a similar for Newell. Yep, there is. Assistant in Vim. You can use this. This is what I use. Yep, can use this. Which is cool. In Newell. Hello. You participate in AdCoder? Nope, I have not participated in AdCoders contest. Right now, I'm just doing code forces. And what do we have here? Global preparation. The program must initialize some of the libcurl functionality globally. Curl global init. Okay, this function will do that, I guess. That means it should be done exactly once, no matter how many times you intended to use the library. Once for your program's entire lifetime is doing this. And it takes one parameter, which is a bit pattern that tells libcurl what to initialize using curl global. Okay, that is a lot of stuff. Handle the easy libcurl. To use the easy interface, you must first create yourself an easy handle. You need one handle for each easy session you want to perform. Basically, you should use one handle for every thread you plan to use for transferring. You must never share the same handle in multiple threads. Okay, get an easy handle with this. We got it. It returns an easy handle. Using that, you proceed to the next step, setting up your preferred actions. A handle is just a logic entity for the upcoming transfer or series of transfer. A handle is just a logic entity for the upcoming transfer or series of transfers. Okay, logic entity, we will go with that. Okay, because we do not have to delve into everything. Not here. This is beside the point. What we need is simply a way to set up a request. This is like very basic thing. You set properties and options for this easy for this handle. Using this, they control how the subsequent okay, this is not sending a request. This is just setting up options for this. For this handle, do this and this. Okay, transfer using the handle made options remain set in the handle until set again to some different. Okay, to something different. They are sticky. Multiple requests using the same handle use the same options. If you at any point would like to blank all previously set inputs, I could use this. Okay. Many of the options you set in libcurl are strings, pointers to data terminated with a 0 byte. Okay. When you set strings with curl easy setup, which is this, libcurl makes its own copy of that. They do not need to be kept around in your application after being set. Okay, one of the most basic properties to be set in the handle is the URL. You set your preferred URL transfer with this in a manner similar to this. You set your preferred URL to transfer with curl opt URL in this manner. Let's assume for a while that you want to receive data as the URL identifies a remote resource you want to get here. Since you write a sort of application that needs this transfer, I assume that you would like to get the data passed to you directly instead of simply getting it passed to standard out. So you write your own function that matches this prototype. Okay, we have to write our own function which returns a number, write data, takes in a pointer to buffer, takes in a size, takes in n size of one member and the number of members. And this, what is this? You tell libcurl to pass all the data to this function by using a function similar to this. Curl write function and write data. Write data is the function and okay, shit. Okay, I think I understand what this means. This is a set thing. Okay. Set option. Set option for this handle curl opt option URL. Okay, that makes sense. And the URL is going to be, let's say, string URL or string SS implicit initialization of undefined template. Why is SS bad? Implicit initialization of undefined template. ST basic string character. What is implicit? What is bad in this? Uh, basic string stream char. Clang implicit initialization of undefined template. Undefined template include bits std c++.h. Okay, now it seems to be better. Okay, so something was not s stream. Okay, cool. And this will get s the basic add-on of code URL. The base URL is this. Okay, https://admin.co.com/ yeah, and then go in year and then colon day hyphen day hyphen then day like literally the day and input this thing. Yep, and the URL here is going to be s dot stuff dot c stuff. Yeah, that's cool. And now I need to pass in a function to this. Set a function like this curl OTP function which has to have this signature. Okay, curl easy set opt on this handle curl opt write function option OPT, and where is all the LSP helping gone? I need to have a function like this. Why do I have it here? Where is nice enough? Right, data, and yep, right data, and okay. Now what do I do? In this, I have a buffer void user p size. Okay, I understand what this means. What is this? But I don't get this and this. Let's see. Right function. This is what we need. And what does user data mean? Set the user data argument with curl OTP data. User data. Yep. Okay, it is not very well defined. Seems. Pass a pointer to your callback function. Pass. This is my callback function, right? Pass a pointer to your callback function, which should match the prototype shown above. This callback function gets called by Libcurl as soon as there is data received that needs to be saved. For most transfers, this callback gets called many times, and each invoke delivers another chunk of data. PTR points to the delivered data, and the size of that data is this. Okay, PTR is the data, and user data is where it is being stored. Okay, PTR points to the delivered data, and the size of the data is uh, NMB. Size is always 1. NMB is the number of data, and the size of individual data chunk is 1. The data passed to this function is not null terminated. That is why we need the size, and this is where we are storing that data. Okay. Okay. And okay, the callback function is passed as much the callback function is passed as much data as possible in all invokes, but you must not make any assumptions. Okay, before that, let's actually not do this. Return I, and before this, let's simply test, because they are saying that if we do not provide this right function, that then the output is going to go to standard output. Then let's see if it is going to standard output. Get data, call this with day 12 and year 2023. Day 12, year 2023. Simply that. Line plus plus get data CPP and Lcurl. Shit. Dot slash a dot I. Okay, it is not here. It is not here. So I think I have to make a request first. Just adding the options is not cool. Yes, of course. Shit. Success, curl, easy, perform, handle. Okay. Get data, curl, easy, perform, on, handle. success and see out if success, then okay, that is a legit comparison. If success, then see out. Got it. I don't have to actually do this because I will see the data if it is a success. No, okay, see out is nothing. Makes sense. Okay, climb out or slash out. Puzzle inputs. Shit. Okay, makes sense. Makes sense. Okay, puzzle inputs differ user by user. That is why I have to go to my inspect, see my cookies, and send this thing with my cookies. Shit, which is a security hazard. Actually, yeah, applications where the cookies are here, and if I show them on stream, it is going to be bad. I would not like to show my cookies on stream. But anyways, let's see. Okay, there is something. There is something there. Okay, so for now, I will copy paste this whole thing. I will write this function of stream because I do not want to accidentally leak my cookies, even though it is not a very big problem for me. I can just log out and log in. But anyways, for now, we will copy paste our input. Input.txt paste. And how do we read through a file in C++? Shit, I actually do not know. Fstream int main auto fstream. Okay, what does this require? No information. Okay, how to read file in C++. Shit, this is bad. I should actually know how to read input file stream. Okay, input file stream. Input file is this, and then file dot open this thing. Okay, and if not is open, then error. Otherwise, read from it line by line. Yeah, or word by word. Okay, I will have it as a stream, it seems. Okay, file stream auto data equals if input file stream on input.txt, and then data dot open. Now I think information, what do I have to provide? Data dot open example.txt. Okay, and now if data dot is open, then cool, but if not open, then cout couldn't read data and exit with 1. Else we have the data here. While get line was the function. While get line was the function. Get line from where to where? Get line from info file to line. Line is a string. Okay. Data dot line. Okay. Now I can traverse through each line. Okay. Cool. Now, what is the question? Question is this: you finally reached the hot springs. You can see a stream rising from secluded areas attached. You can see a stream rising from the secluded areas attached to the primary ornate building. As you turn to enter, the researcher stops you. Wait, I thought you were looking for the hot springs, weren't you? You indicated that this definitely looks like hot springs to you. Oh, sorry, common mistake. This is actually the onsen. The hot springs are next door. This is onsen. What is an onsen? Onsen is this, some Japanese thing. You look in the direction the researcher is pointing and suddenly notice the massive metal like helixes towering, helixes towering overhead. This way, it only takes you a few more steps to reach the main gate of the massive fenced-off area containing the springs. You go through the gate and into a small administrative building. Hello, what brings you to the hot springs today? Sorry, they are not very hot right now. We are having a lava shortage at the moment. You ask about the missing machine parts for Desert Island. Oh, all of Gear Island is currently offline. Nothing is being manufactured at the moment. Not until we get more lava to heat our forges and our springs. The springs aren't very springy unless they are hot. The springs aren't very springy unless they are hot. Okay. Say, could you go up and see why the lava stopped flowing? The springs are too cold for normal operation, but we should be able to find one springy enough to launch you up there. There is just one problem. Many of the springs have fallen into disrepair, so they are not actually sure which springs would even be safe to use. Worse yet, their condition records of which springs are damaged. Your puzzle input are also damaged. You will need to help them repair the damaged records. In the giant field just outside, the springs are arranged into two rows. For each row, the condition record records show every spring, whether it is optional, operational. This is spring is optional, operational, or damaged. Damaged spring is represented by this. This is the part of the condition records that is itself damaged. For some springs, it simply is unknown. Okay, question mark, whether the spring is operational or damaged. However, the engineer that punched the condition records also duplicated some of this information in a different format. After the list of the springs for a given row, the size of each contiguous group of damaged size of each contiguous group of damaged strings is listed in the order those groups appear in the row. This list always accounts for every damaged spring, and each number is the entire size of its contiguous group. That this list always accounts for every damaged spring. Okay, always accounts for every damaged spring, and each number is the entire size of its contiguous group. That is, groups are always separated by at least one operational string. This would be a group of 4, but never a group of 2 and 2. So condition records with no unknown spring conditions might look like this. Okay, some record in which we know the condition of every string, it might look like this. Here we have 1 1 and 3, 1 1 and 3, 1 1 and 3, 1 1 and 3. Okay, however, the condition records are partially damaged. Some of the springs conditions are actually unknown, represented by a question mark. Okay, equipped with this information, it is your job to figure out how many different arrangements of operational and broken springs fit the given criteria in each row. Okay, okay. In the first line, there is exactly one way. one way separate groups of 1 and 3 broken springs in that order can appear in that row. The first 3 unknown springs must be broken, then operational, then broken, making the whole row like this. Thus, okay, that makes sense. That makes sense. 1, 1, and 3. There is only one way that you could arrange this whole thing by having one broken string here, one broken string here, and this one has to be correct, like working, because you want to separate this one and this one by 1 at least. In the first line, this thing, there is exactly one configuration. The second line is more interesting. Okay, 1, 1, 3. Okay, I need to have one here to make this a group of 3, and then I could have my one here and one here, one here and the other one here, one here, the other one here, and one here, the other one here. That is 4. Is it 4? 4. Yep, 4. Interesting. This could be a total of 4 different arrangements. The last question mark must always be broken to satisfy the final contiguous group of 3 broken strings. And each this must hide exactly one of the 2 broken springs. Neither this could be both broken springs, but they would form a single contiguous string. Yes, so we cannot make both of these broken. It would make a single contiguous string of 2 broken springs, but we do not want that. We want only size 1. Okay, and to satisfy the final contiguous group of 3 broken strings, and yeah, the last line is actually consisting with 10 different arrangements, and these are the 10 different arrangements for that one. In this example, the number of pairs are like this, adding all the possibilities of arrangements in this is 21. So for our puzzle input, I did this one like more than 1 year ago in advent of code. Do we get all the test cases unlike code forces? No, there are no test cases. There is just this one single input. You have to run your algorithm, whatever you write on this, no matter what language, anything. Just run your program on this according to this thing, and whatever is the output that you get from your algorithm, paste it here. And if it is correct, you will get right, and if it is not, then it will be wrong. So yeah, part 1. I did part 1 more than a year ago and in JavaScript, and let's see if I'm better than before. Okay, for this long answer initially equals 0. I'm second year. How should I do CP starting now? Just I would suggest CP31. Yep, CP31 is cool. You can start from here. CP31. Solve these problems and get to know stuff. And that is, I guess, one of the obvious advices. Just practice and get line. So in this, I have this thing. I get a line like this. What I need is to separate these things and put them in an array. And I can put this in a not in a tuple because the length of this thing could be really big. Yep. 1, 2, 3, 4, anything. Yep. So separate this line on this. All right. So shit. Okay, I will have to iterate through this thing, and I think there should be better functions in C++ for doing what I want to do. How to split a string in C++. Get line using get line. Okay. I have a string like this, a vector of strings and a string segment, and then I is stream input, string stream text, create an input string. Okay, get line. Okay, shit. Okay, so find line dot begin to line dot end. Look for this thing, and then I can create a stream and vector int groups, and then while get line, call this on. I have to create a input file stream, input string stream called groups grps, and pass in it. Start from here, it plus 1 or it plus plus, and go till line dot end. Is that cool? That is apparently not cool. Can I not create this using a iterator? Find and substring. Okay, delimiter is this. Yep. Find delimiter end. That is size. Okay, what is find return? Char pointer. What does this thing return? Wrapper iterator around a character pointer, which should have worked. No matching constructor. Okay, that is bad. Okay, if end is not equal to this end pause, then no position, then parts dot pushback text substring from starting till end minus start. What is start? Start is 0. Okay. Okay, and start push, and then end equals find delimiter again. Any other way? C style strings and flexible approach. Okay, but okay, I string stream, let's call it group, and make our line equal to that, and then while yep, I also need to find create yep a vector of integer groups and string num, and while get line data, not on data but on grp, get this into num on the delimiter. This is even worse than I thought. Shit. Yep, this is even worse than I thought. String nums starts from find, okay, this is that. Auto starts equals find line dot begin line dot end, look for space, and then string nums starts at start. Can I do this? Start comma line dot end. Yep, cool. That is nums, right? And now input file is string groups nums, cool, and vector integer groups and string num while get line from nums into num, not nums, from groups into nums, and the delimiter is comma. Cool. Yep, cool. And groups dot pushback int num. Only string. Okay, okay. To integer. Shit, how to convert a string to an integer? To int. C++ is really hard for development. Shit. STOI. Okay, I can use that. Let's see. After creating this, let's see. See out if this thing works. And I would like to start tmux here, which would be cool. Tmux attach or tmux session. Name is going to be AOC or shit. Attach session AOC tmux new win new session S AOC, cool. And here a new window with the name ZSH, cool. And here rename this window, not kill the window, rename window to new, that is cool. And part one, start part one here, and here blank plus plus part one F C L cult. Shit, that is bad. Actually bad. I saw literally nothing. It doesn't work. Yep, dot slash out. Okay, hi, I am at least getting here, but I'm not getting any line out of data. Okay, I cannot do that. It seems str. Wait, what? Open. How to split a string, how to convert a string, how to read file in C++. Shit. Yep, I did that. Input file string and yep, input file string with this, and this seems to be the only way. String line and keep getting line. Okay, that doesn't work. Data, I have anything in the data. Okay, it is not exiting here. That's good. Input.txt. I have the data in input.txt. Yes, I have the data in input.txt. Input.txt. Input file stream here. Data open. Here I'm not doing any data open. This creates a file stream object named input file and attempts to open it automatically, I guess. If I skip this and now try to output, and it does work, it does work, it does work. Cool. Do not do this. Yep. Let's see. Okay. Here I have 316 at the end. Do I have 316 here at the end? I do have 316 at the end, and above that I have 1312, and here also I have 12. So at least that much is cool. At least that much is cool. Mhm. Pattern starts from line dot begin and goes till start. Let's output the pattern and see if it works. Yep, here we have till double question mark at the end, and yep, till double question mark at the end. So that is being read correctly. Now what do I want? What do we want? We have this data, we have the other data also. Now what can be the approach? What can be the approach? Every question mark can be a fix, correctly working is spring or a broken spring, and that depends on this. That depends on this. So I can begin from here for every string. I can begin from here and make the first one equal to this. Right? Make the first one, let's say broken, and then whatever the thing is, whatever the number of configurations are for this remaining string would be the number of configurations for this thing in two ways. Yeah. So at every position, I either convert this into a fixed string or into a broken string and then ask how many configurations are there for both and add them. That would be the answer for this. But that is going to take a lot of memory. So we need to fix some things. We can optimize later. Premature optimization is the root of all evil, and this is also cool. I would like to go to the washroom and I will be right back in a minute. Yep, I'll be right back. Wait a minute. For that question, I can actually write a function that will take in this thing and take in this thing and return the correct answer. It will return a long and it will be called solve and it will take in a string, let's say s, and to be specific, a reference to x and to s. And just doing this question, I have realized my C++ skills are really bad in development side. And this will take in a vector of integers, a reference to that, and it will be called groups, and then at the end it will return the thing long this, and at the end return the response. This function will get this thing and this thing and needs to return the answer. So this can go and find the first question mark and ask, is it okay to put a question mark here? Yep, is it okay to put a question mark here? And if it is, then put the question mark there and ask how many ways there are to get to this configuration. I think I should not, yeah. Whenever I see a question mark, yep, I will ask myself, is it okay to put a question mark there or not? And I can change these numbers to represent the ones that are remaining. But yep, that would be bad. That would be bad. Because in something like this, if I say 1, then this could take this as 1. But in actuality, I need a 3, a group of 3. Okay. So count, a total count would be nice. A total count would be nice. If I know the total number of hashes, and then I would know how many are remaining. And if it comes out to be 0, then we are cool. Or I could go just go through this once. I could just go through this once and count the number of hashes myself. That would also be nice. Int hashes equals 0, and for char CNS, char CNS, and this, if C equals a hash, then hashes plus plus. I will have the number of hashes here, and T hashes equals accumulate groups dot begin and groups dot end comma 0. Right now, if hashes, the ones that I have, equals total hashes, then return 0. There are no possible configurations, or return 1. Just this configuration that we have here. That is the only one possible. Else, if not, I think I should, yeah, I should send this to the function itself instead of doing this every time. For every group, after every group, S is nothing, that is just pattern go, and this function will also get int hashes and int t hashes. If that is equal, then return false 26, and copy, go down 9, paste, and yep, remove the last character, call this function, and solve answer plus equals this thing. This will take in pattern, and this will take in pattern, and the whole function definition is this thing. Pattern and groups and hashes and t hashes. Yep. The only thing that remains is the implementation of this function. Implementation of this function. Okay, if that is one of the end cases when we have added everything that we can, then that is cool. Now I will iterate for int I equals 0, I less than s dot size and I plus plus. If si equals question mark, then I have a choice. If yes, I need additional information other than this. Yes, I need additional information other than this. Yep. And it would be really good if I could pass it through function and functions. Vector of integers I reference would be nice to present what is present and what I need. Nice name could be target and current, and remove this. I can calculate this while I am iterating here. Target, okay. Vector of integer called current, and for int I equals 0, I less than pattern dot size I plus plus and if s, okay, and also int c equals 0 if si equals question mark and c plus plus, else if si, what is s? S is nothing. There is only pattern, not even patterns. Pattern, and yep. And here pattern I, if pattern I equals dot or hash. That is crazy. Dot or hash. Yep. Water. It's it. Why does it seem more complicated than it needs to be? Okay, I have this. I need to know the number of question marks and the number of hashes, and the number of dots is inambiguous. That does not concern me. That is very cool. And the number of dots actually could be removed. The number of dots actually could be shrink. And it does not matter how many dots I have in the middle. 3 or 1, they are the same. I think I should not do this. Yes, I should not do this. I should not do this. This is bad. The earlier approach was finer in some sense. And by the way, this, yeah, this is fine. This decision tree in Vim is pretty cool. You can just go back in history. This history tree is pretty cool. Yep. And yeah, okay. Int v equals 0 and or g equals 0. This represents which one of this group I'm trying to fill first. Uh, what I need to know is, given a certain place, can I add, can I make this string broken? Here I cannot. Why can I not? Because, okay, making it broken or not depends on what is going to be and what has been, and also on which thing I am here. Individually. Given a pattern, I just need to figure out how do I figure out whether I can make this string broken or not. That is the only thing. I cannot make this string broken here, this one specifically, because here is one, and I need a group of one string that is broken, and here this one is broken, and if I were to make this one broken, then it would be not possible. So maybe I can just first go through the whole thing and see the places where I can add, and then add the string there, because I do need future information for that. So here I cannot do this, here I cannot do this, here I can, here I can, but here can I, here I cannot, here I cannot, here I cannot add the string. Big shit, here I can. This, why is this more complicated? Shit, why is this complicated? This is just a D12 question. Okay, let's go with a simpler example. Here we have 1. Whenever I see a question mark, I have a choice. Do I add a string here or I don't add a string here? Do I make this current string broken or not? Do I make a hash here or I not? Or I don't? And here I can, because I have this future information. Okay, what are the parameters which I need to keep in mind? One is this, that the total count of this thing cannot exceed the total number of hashes I have here. That is one thing, absolutely necessary. And then second, I can maybe go through this string once and see how many strings are left in each group which I need to fulfill. So if I go through this once, and going from the start or end does not make any difference, does not have any difference. If I go from the start and I see a question mark, I will not count it. If I see another question mark, I will not count it. If I see another, I will not count it. And then when I see a hash, where do I put this hash? Do I put this in this category, in this group, or in this group? Who would know? Because I would have to add this into this group, because there are 3 hashes and 3 is this. So I do not need a group of 3 hashes because I already have it. I need a group, 2 groups of 1 hashes. One is can be here, one can be here, and there is no other possible configuration for this. But how do I tell my computer that? As a human, I can see that. Okay, hash. I see hash, 3 hashes. Okay, first of all, I can just go through this thing and count the number of hashes and sum these hashes, which I'm already doing here. Hashes is the number of hashes that I have, and T hashes is the total number of hashes. And if the hashes that I have equals the total number of hashes, then we are cool to go. And one, I would say, loop invariant is that S is a possible pattern. That is, whatever S is, it is a possible pattern that I could have given the constraints. That is one loop invariant. So whenever I'm calling this function again recursively, I have to make sure that whatever S I pass down the line, it is still possible to have it. It is still a stable pattern. Or let's say do put a 1 here. If I do put a 1 here, and I know that there are 2 ones remaining, Okay, let's say this is a hash. Let's say we go to Excalibur. Yo, uh, okay, this is the thing that we have, and yep, this is the thing that we have. Let's say we make this into a hash, and now I have a choice to convert this thing to hash or not, this particular one. How would I know? If I do convert this into a hash, I would have this as hash. That is bad. That is wrong. If I do convert this thing, this particular one into a hash, then okay, I need a way which I can go through the string and just see the groups and compare them with the given groups. Compare these groups with this given group. And if they match, then it is cool. If they match, then it is cool. And through this, I will, okay, okay. So I will start counting from here and I will go forward, go forward, go forward. Or I can write a function which will do that, okay, which will take in a something like this and then return a vector, and maybe even it will take this vector itself, this vector also, and this pattern, and tell me, is this pattern possible given this thing here? So what this function will do is it will go through this, it will go through this and make a list here, and for this particular pattern it would make a list 1 and 3. And do I see 1 and 3 in this? I do see 1 and 3 in this, but I could also have had lower than 1 and 3. First of all, the sum of this thing has to be lower than this thing. That is one thing. And second of all, given this thing 1 3, how do I make sure that it abides by this pattern 1 1 3? Maybe it is just that I am stupid. Fuck. Okay, I guess I should come back to this problem at some point later after taking a walk. And while that happens, we can do some CSES. Shit, I don't have code. Was was it hard? It seems to be hard. Okay, now CSES. And shit, we haven't done anything knapsack, not knapsacking all the way. So I guess a clickbait. This is a clickbait. Going to CSES, CD, dynamic programming, ls, and yep, run here. You know that an array has n integers between 1 and m, and the absolute difference between two adjacent values is at most 1. Given a description of the array where some values may be unknown, your task is to count the number of arrays that the match this arrays that match the description. Okay. In the first input line, two integers n and m are given, the array size and the upper bound for each value. The next line, n, has integers. This, okay, value 0 does denotes an unknown value. So I have a choice. Okay, and the difference between two is at most 1. Difference between 2 is at most 1. So here the answer is, yeah, cool. Wait, why is this hard? Makes sense, makes sense. There would be a lot of different values in the middle. Yep, shit. Yeah, this is a recursion. Seems to be recursion. CSE N M N M taken N and M both, and then I have to take in the array. Vi a size will be N for auto reference a Cn into X. And what is Vi? Vi is nothing. Vi is a vector of integers. Cool. And now I have to iterate for int I equals 0, I less than n, I plus plus. For every vector, if ai equals 0, or if not ai, if not ai, then I need to see whatever the number is on the left or on the right, and I need to find anchor points. I need to find anchor points. Yep, I cannot do this with this. If if ai does exist, then I need to look at its left and at its right. Yep. And I will have to create a function. Yes, I will have to create a function which will return a long answer. Let's call it solve vector integer. Let's call it v, or aa is fine, and that is enough. And const int m equals 1e9 plus 7. And what this will do is for int I equals 0, I less than a dot size I plus plus. If a I, if ai is a number, and if I, that is, I can go back, and if the back, no, I cannot go back. I cannot. I can go back. I can go back. Upper bound. There is also fucking upper bound. Okay. I can break this up. I can break this up on anchor points. Okay. If I have a pattern like this, 0, 0, 0, some number 3, 5, there is comma in between all of them. Make it white. Yep. Yep. Then I can break this up, all of these zeros, and yes, I can send to my function this value, the possible values for this would manage the possible values for this, would cause some possible values for this, some possible values for this, but there is also anchor on the right, so I cannot just have any possible values for this. Shit. So if I start going from the left side and choosing every possible value that I can for this O, and start making a recursion calls, and this will make 3 recursion function calls, because the difference cannot be greater than 1. So if there is 1 here, I could keep this as 0. I could convert this into a 1, this number, or I could convert this into a 2. And in both of all of these three cases, the difference is not greater than 1. And then in turn, they will call different 3 calls for this number, for this next number. So 3 power n for every 0 in this. 3 power n for, yeah, and where n is the number of zeros. And what I have to make sure, what I just need to know is, given a 0, what are the possible values that it could have, and maybe write a function that can find that for this 0, for a particular 0, and whatever that number is, let's call it x. I have to multiply that for every 0 that there is. Here there is only 1 0 and it can have 3 values, so answer is 3, which is cool. Nothing works. Hi bro, I am new here. Can you tell what competitive programming is? Yep, competitive programming is not comma AI. You have some websites, or even before that, competitive programming, you have some websites, yes, like, yeah. And on these websites, this is Codeforces, a competitive programming website, which is Russian, and you have a lot of websites. And here there are contests, and in each contest you participate, there are a bunch of questions, starting from the easier one, labeled as A, B, C, D, and F. F is the hardest. And in each contest, you have to solve these questions. And what matters is how fast you submit your solution after the contest began. And yep, that is basically what matters. How many questions you solved and how fast you were in solving them. That matters. And depending on how your performance was, there is a rating system which goes up and down. Depending on your performance, you get some points, and your points determine how your rating changes. What is rating? This thing. I am from Antarctica and my rating is 1200, which is noob, which is newbie rating, which is very low, which is very, very low. So I'm trying to increase it. And yeah, and how does your rating change? It is like chess. When you play chess, your elo goes up or down depending on whether you win or lose. But in chess, you only have two people competing against each other. In contests, there are a lot of people competing against each other, and depending on their performance, their rating changes. Like, yep, maybe in this one, in this contest, there were 33,000 people, and for me, my rating, my among those 33,000, I was at this position, 7,600. And depending on that, my rating changed a bit. My rating increased by 7 points, which is pathetic. It's very small. My rating increased just by 7 points. Yeah, that is competitive programming. Yeah, yeah, that is a joke, by the way. Course, if you are a beginner, like beginner to programming itself, then I would say the same thing. CS50, you can take this course, CS50 edX. Go to this website, you can take this course. This has 12 lectures spanning on 12 weeks, like this, 12 weeks. And then at the end of each lecture, you have some other, like, semi small lectures and some shorts on the topics which were explained in the main lecture. And then there are problem sets that you have to do and submit after every lecture. And that is good. That is pretty cool. You can do this. CS50, it is by Harvard, like the Harvard University, and it is free. You can do that. Yep, I am a student. Shit, okay, you are talking among yourselves. Okay, so yeah, CS50 would be the best thing. Cheating happening these days on Code Force is literally newbie solving to yeah, yeah, that happens. But I guess the main thing is, in even when people are cheating, you know where you are and you can grow, right? In some interviews, if they are getting interviews, they won't be able to answer the questions. So you are better off. Yeah, teaching sucks in college. You have to teach yourself. And this is the best thing, literally the best thing that you can do when you just started college. CS50 is cool. Yep, you can do CS50. It is cool. Very cool. One of the best things you could do. And down the road, you will be able to do questions like this, which are hard. M cannot will not be greater than 100. Okay. Hmm. Uh, let's say I have a number here, A, and I have a number here, B, and I have three zeros. Then this thing has three possibilities, A minus 1 and A and A plus 1. We can write this as A plus 1 and A minus 1. Three possibilities for this. 3 multiply by this thing. How many total possibilities would be for this thing? Because of this, it would be 3 plus 1. One more possibilities, A plus 2 and A minus, this is minus, A minus 2, and all of these same possibilities also here. So into 5, and then if you go to this third 0, then 7 possibilities in total for this 0 into 7. But this thing also enforces something. So at the end, I could say that there is going to be a range on this thing. Because of this, there is going to be a range that this thing can take because of this, and there is going to be a range on this thing because of this. Because of this B, there is also going to be a range on this. I can take their subset, their intersection, and multiply that, and do this for every single number. Take, multiply, take the intersection, multiply. That is not very dynamic programming thingy. That is more like, let's make do. Yeah, you can just start by taking this course. This is for beginners, Introduction to Computer Science. You can start by taking this course. You can go to edX website. I sent the link here in the chat. You can go there, register, and start taking the course. And also, the lectures are on YouTube for free. All the lectures are on YouTube, but it won't mean a lot if you are not solving the problem sets that come with this lecture. So you would have to solve them, and only then you would get the certificate. Even though that certificate does not mean much, the main thing is that you did solve the questions, which is cool. And yep, there is a lot of lag delay here. That is why I cannot talk directly in real time, IRL, uh, in real life. Shit. The first input line has two integers and what would be the dynamic programming approach? What data do I? Okay, shit. There is going to be a lot of recursion call, and if some whenever I see a number with 0, it has three possibilities: a minus 1, a, and a plus 1. I can put this number equal to a minus 1, then equal to a, and then equal to a plus 1, and find the possibilities for the whole string when this 0 equals to these three things, and add it here, and then do the same thing again for the smaller ones, and add what would be the base conditions. Base conditions would be when in the given range of zeros in for which I was solving for, there are no more zeros, every zero is covered, and the boundary of these zeros do not conflict with whatever the initial AB values were there. And let's say if I was coming from left to right, then this last zero has to agree with this B here. Yep, this last zero has to. Yep. Yep, this last zero has to agree with this B here. If I'm going from left to right. But that just somehow seems unnecessary. Only 32,000 people have been able to solve this. Okay, so this one is definitely more difficult than the ones that I have done. Those ones were really easy. This one gave me a lot of trouble. This one also gave me a lot of trouble. This one, and wait, no, bookshop was easy. Bookshop was pretty easy. Yeah, I got it right in one try. Bookshop was easy. This one was pretty hard because of some optimizations. But array description, yo, for Python, there is one thing, not channels, but this CSFT program also has a course for Python, which is cool, which is like actually cool. Yep, this computer science for Python programming. Computer science for Python programming. And yeah, that is cool. This thing, computer science with Python. This is 10 weeks long, but you can probably or very easily do this faster than 10 weeks. You will learn about all of these things, etc., etc., regular expressions, object-oriented programming, everything. That is cool. And all of these courses are free and from Harvard, which is amazing. And yeah, that's cool. But okay, Okay, what do I know in this? And what is the state that I need to store? And let's say I do not know that this can be solved using dynamic programming, but I do know. Okay, if I think of a recursive approach, the subproblems do over uh, do overlap. The subproblems do overlap. So this is a bad example. An example like 1 0 0 0 0 1 would be good. So this 0, I can start a loop where I will find the possible things that I could have, possible values that I could have for this, and call the function again with that value. So let's say I will call the function where 1, I cannot have values equal to 0, yeah, 10 power 5. What would be the time complexity of this thing? Time complexity would be really high, really high, really high, really high. Time complexity would be really high, really fucking high. Xi is going to be between 0 and m. Let's say for it is not actually that high. For n elements, I am going through m possible states. What I need to make sure, and m is at max 100. So 10 power 7, that is very much doable. What I need to make sure is I do not recount and I do not over calculate. I do not find answers for things that I have already found the answers for. Right. What would that data structure look like? Okay, I can keep a memoization data structure in which I can store in a pair first the index I, which would contain the location of this 0, and then a number x. That is, when I put x onto the ith location, what what are the number of configurations? And that is actually cool. That is actually cool. I can do that. Yep, use a map for that. Pair, a pair of integers would map to some integer. A pair of integers would map to an integer. That would be cool. Let's create a memo map of pair of integers going to integers called memo. Memo? Yes, memo. Or maybe can I create a table here? Brute force. If I create a table of size 10 power 7, that would be not really good. With 10 to the power 7 integers would not be really good. The memory that I can use is 500 MBs. So 10 to the power 7 into 4 bytes. That is something. I think it is 40 MB. This thing is equivalent to 40 MBs, which is within the limit. Right now, I am solving this question on CSES. I'm trying to solve this question. Whoa. Starting with C++ is going to be very horrible. Starting with C++ is very, very horrible. C++ is very complicated, very complicated. People get scared of C++. It is way more complicated than it needs to be. And Python would be a really good start. You can start with Python. You know that an array has an integers between 1 and fuck. I can even store the whole thing. If I have a table, this has size of m and here n every element, and whenever I see a 0, I put it equal to 1, then 2, then 3, then 4, then till m. But that is not good. That is very bad. A map would be much better. Solve, yes, solve for this vector, solve for this vector. Yep. So yes, okay. I think this whenever I see a sequence, I need to identify the number of zeros, the where the zeros are, and also the fixed points. Fixed points would be cool. Fixed points. Yeah. Okay, so I will look for fixed points. If AI isn't equal to 0, if AI, then what do I do? If I find AI, right? Now if I, then I will see if I and AI minus I and not AI minus 1, then solve. But before solve, make this a reference, and AI minus I, put it equal to AI minus AI minus 1. Solve for A. And here I would have long response starting at is 0, and whatever solve returns plus equals solve, and then AI minus 1 equals AI, and then yeah, and then let's solve A, and then AI minus 1 equals AI plus 1. And I also have to make sure that it is within the range. It has to be within the range. Yep. Between 1 and m, right? So I can always make this equal. So this part is always doable. But for others, I have to check if AI isn't equal to 1, then AI minus 1 equals AI minus 1, and rest plus equals solve rest, solve A, and if AI isn't equal to m, and what is m? Then AI minus 1 equals AI plus 1, and rest plus equals solve A. And that is cool. And what is m? That is a good question. Again, return rest. Okay, right, but then yes, I have to repeat this, repeat this, repeat this. And also use memoization. And to repeat this, while AI and int x equals I, while x and while x. Wait, I can actually do this. In this, wherever I see I, yep, substitute I with x globally. Cool. Okay, yeah, maybe not here. Yep, 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 yep. And at the end, do x minus minus. Go back and see if there were any zeros at the back. And before calling this function, see if map appear the index is x minus 1 comma, and the value is ax. If this double counting shit, I do not want to do double counting, and I am not doing double counting. That is cool. If map, then rest plus equals, wait, what is map? Rest plus equals memo for x minus I a x. else, yep, that is when it is equal. And here, if this, and internally, if memo x minus 1 at this index, if I ever put x minus 1, it was then resolution plus take it from the memory x minus 1 with the value a x minus 1, else if that wasn't the case, this, and here do something very similar. Oh, no, internally for instead of this, change this into a plus and change this into a plus and in this into a plus, right? And also update into memo question mark x minus 1 with value ax equals shit, okay, long, let's call this c equal solve a comma m c add c and this thing equals c. And also here long c equals solve a comma m c and add this into the memory x minus 1 when it had the value a x minus 1 that is now equal to c. And here also do similar thing, long c equals solve a comma m and then change till this c and here memo x minus 1 comma a x plus 1 equals c. That is cool. That is cool. Okay. And keep moving back, keep moving back, keep moving back. Yep. It just feels like something is wrong. I do not have any base cases. I do not have any base cases. And this seems to be way more complicated than it needs to be somehow. Good C. Shit. Good CGPA. Nah. My CGPA is 4 or 5 something. It is very bad. If AI and maintaining CGPA is like, to me feels like there is no point in maintaining CGPA unless my goal is to get a placement through college, because I would be much better off instead of investing my time into getting a nice CGPA. I could invest my time in learning to code and I could get a off-campus placement. So that is my idea. But also if the topics that are like if the subjects are not way are not really bad, then there is like you can read about them. If it is something maths related, if it is operating system, then you can read about them. Networking at school. And shoot. Okay, here I checked something. Yep, this thing. And wait, there was a shit. Okay. How to jump from parentheses and when percent. Okay. If I'm here, I can use percent, and yes, I can use percent. That is cool. So in here, I checked for this condition. if AI is something, then I'm looking for, and then I'm looking to its left and solving that particular block. Now I need to look to its right and solve that particular block. And shit, what if fuck, I messed up. Base conditions. My base conditions have to be really cool. My base conditions have to be really fucking cool. No, shit. This is shit. This is not making sense. This seems to be really bad. Got internships. Yeah, like there are these subjects like BEEG, which I'm not interested in. Yeah, you cannot skip them because you have to remain in college. But yeah, if they just do the minimal work that is required and focus more on programming, that is cool. That is cool. And you will see yourself struggle. Like, I'm unable to solve this question. I just cannot even begin to fathom how do I begin solving this question. Let's try to do some shit. There are no easier other questions. Everything is hard because the number of submissions is really low for all the rest questions, all rest of the questions. And this one seems to be the easiest among them. Rod cutting, I can do rod cutting. There was a rod cutting question at some point. Edit distance, we can do edit distance. Yesterday we did some edit distance. Okay, there is no rod cutting, but we can do edit distance. This one. Shit, this is the exact same thing that we wrote. Okay, the edit distance between two strings is the minimum number of operations required to transform one string into another string. And yes, that is cool. We can hopefully we can do at least this one. And what do we get? We get two strings, string A and B. String A and B, uh, or starting and target would be much better names. After this, after taking in the strings, I needed to write a recursive function which will return a number. And yeah, solve. This will take in string S and string T, or not, or maybe not, maybe not. I can do a tabular thing. The tabular representation, or wait, I will have to go to the washroom. I'll be right back. The CGPA effect off campus. Nah, if you have a solid resume, of projects and your skills are really good, then it won't matter. At least that is what I think. Hackathon, what is that? In hackathons, shit. Okay. In hackathons, you have some problem statements. That is the organization who is organizing the hackathon, they give you some problem statements. That is something like something like help people connect or build some app for student welfare education. And given that problem statement, you conjure up some idea which you could implement. You write some code, you maybe create a website or some application, Android or iOS, and present your idea as an entrepreneur to the judges. And if they think your idea is solid and your presentation is solid and what you have written, the prototype, if that is pretty good, then you might win the hackathon. That is hackathon. And you do write some code before the actual hackathon, but on the day of the hackathons, you get 24 hours or 36 hours or 48 hours. You stay in a single room or hall, and there are other competitors, and you all compete. And at the end, you showcase your things to the judge, and the judges decide who wins and who loses. That is cool. Edit distance. Why am I unable to solve this when I did this yesterday? Vector, integers. Let's call this DP. Hmm. Whether I do choose this or I do not. Yes, makes sense. S dot size, comma, vector int t dot size. Okay, what even am I trying to do here? If I have M O V I, this is I E, and this is supposed to be love. L, this is supposed to be love. L O V E, and there is a table, something like this. And here to convert this thing, shit, yes, to convert this thing into this thing, I need one operation. To convert this thing into this whole thing, I need two operations. To convert this whole thing into this thing, three, four, five. And here I need two operations. Here I need one operation. And yep, the answer would be this thing. So at any given cell, I either convert, I either remove both, or either I go there, or I go there, or I go there. Depending on these three things. Yep, yep. and the size is the size of this thing. Cool. So for int constraints 5,000 into 5,000, that is cool. Have you participated in any, like, what was your experience? So is it done in groups? Yep, it is done in groups. Hackathons are done in groups, and I participated in my first year in 2 hackathons, and I was totally obliterated. We didn't win a single thing. We, like, in the hackathon there was a small activity in which you had to arrange cups. Me and my friend won that little prize for arranging cups, but for the hackathon itself, we weren't able to do anything. That is bad. I equals 0, I less than s dot size, let's say x comma y, and x equals s dot size, and y equals t dot size, and yep, x comma vector int y y. And if you have, like, a lot of doubts, a lot of questions, then maybe you can even join the Discord. There is a Discord channel somehow. Yes, I do have a Discord. Like, if you go to the description, there is a link to a Discord channel. If you want, you can join. There are other people there. And hello, ethics, how are you? And you can see we are struggling here with this question. We are trying to solve this question, edit distance. And we did this yesterday, but now we have to reformulate how we did this yesterday. But before coming to this question, we were just unable to do this question. And it would be really cool if you could have a look at this and maybe share something. Array description. This was horrible. We were just unable to do this question, which is bad. And now in a loop. But yeah, this question, edit distance, I got this pretty much. I can do this. J equals 0, j less than y, and j plus plus. Now, initial condition, dp 0. Shit. Okay, I can do this much better. Yes, I can. Yeah, fuck yeah. Yep. Yes. 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 Shit. Yes. Yes. We can do much better than this time complexity. Uh, Integer. We can save space. Does not matter actually, I think. Yes. Yes. Y. And then for int I equals 0, I less than x, I plus plus for every row in our supposed table, and int j equals y minus 1, while j greater than equal to 0 and j minus minus. And here deep Okay, we are building up. We are Can I do this in one dimension? Because I need to get to this and to this and to this. It would be cool. But I also need data in this one, and these two are overlapping in that. Getting access to this thing is cool. Getting access to this thing is easy. But getting access to this thing. Okay, let's begin. If I have this first row and I start iterating from the end, either I remove the character on this is in this string, or I remove the character from this string. Shit. This is bottom up. Plus one, plus one, 6. If I go there, that would be the cost. And if I go there, that is remove this character and this character both. Okay, the recursive function. The recursive function is like invite f of a comma b equals f of a minus 1 comma b plus 1, or minimum of f of a minus b, a minus 1, b plus 1, comma f of a comma b minus 1 plus 1, comma f of a minus 1 b minus 1, and plus 1 conditionally, plus 1 conditionally. That is the recursive function, and I need access to now. I need access to the current value and the updated value. Let's start with two-dimensional array, right? For parent I, and I can start iterating bottom up for int j equals 0, j less than y, and j plus plus, And did I initialize dp 0? I don't have to. I have to take the minimum. So dp will be initialized. I j equals maximum 0 0 equals s0 equals s t0 not equal to t0. If they are not equal, then 1. Then you start iterating. If j, I can go back. So dpi j will be equal to 1 plus dpi j minus 1. Yes. And then if iota dp 0 dot begin and dp 0 dot end and s0 isn't equal to p0, then 1, then begin with 1, otherwise don't. dp I j equals dp I minus 1 j plus 1, one cost for this, and then if j, then dp I j equals minimum on dp I, it will have a few values. It will have a few values. Let me show you have a few values. So dp I j comma, that will be the one of the values, 1 plus dp I j minus 1 comma dp I minus 1, j minus 1 plus condition plus s I is not equal to tj. See how db x minus 1 y minus 1 and a new line. If this works, okay, okay, it does work, it does work, it does work. We only have to optimize this. That is the one thing. Like what is your journey? Shit, I'm my third year just started, and in my first year, I first of all did CS50. I went to a few places like I saw ads, and I went to a conference in Noida, which was pretty good. But yeah, basically to sum it all, I have tried to do stuff, but I haven't actually done stuff which I haven't done any concrete stuff to which I can point to and say, look at this, this is what I did. Everything is just a little bit of this, a little bit of that, but nothing concretely. I bought a few courses, but didn't complete them. So yeah, it is just a little bit of this, a little bit of that, but not anything concrete. But now I'm trying to do concrete competitive programming. That is the whole journey, if you will. Let's try to submit this if this works. And I think the only problem with this would be if yeah, and the only problem would be time complexity. Yo, documents programming, competitive programming, CSES, DB, and we must have edit distance somewhere, which is right here, C++20. Okay, cool, cool. Time com. Shit. Okay. In okay. Now we should be good. Yep. Yep. Now we should be good. Submit. Let's see. Yeah, code stuff is cool. Wrong answer. Okay, wrong answer is not acceptable. I will not look at the test case in which I got the wrong answer, but just here. Vector int y iota begin. Yes. Both the strings cannot be empty, right? Both the strings cannot be empty. At least there is one character always. Okay, so there is some edge case, edge case, edge case. Okay, edge case. Wait, is it? No, yeah, no, it is not overflow error. That is cool. Well, let's see. I think I've written the correct thing. I shouldn't be getting the wrong answer. Okay, it is off by 1. Where do I even look? It is off by 1. That is crazy. CDDB, ls line plus plus array description, nope, edit distance, start. That is just one string. There were two. Shit, that is two strings. Okay, my bad. It is looking for two strings. Say one is this, copy, paste, and the other one is this. Can I not paste big things in this? Yep, seems like that. I can paste big things. This is going to work. Yeah, I did start from scratch, and yeah, the first thing that I did was CS50. Yep, this is the first thing that I ever did in computer programming, and yep, it's been 2 years. And ethics, I would like to know, like, since you have been here for quite some time, are you in the Discord server? And if you are, it would be cool to talk to you in the Discord and maybe get some opinion on how to solve these questions. Edit distance and array description. And let's look at the code that I wrote yesterday. Yesterday I wrote cd. It is not, yeah, there it is. Edit distance. Yep, yep. Look at this. Look at this. Yesterday, this is what I wrote. This looks very beautiful compared to what shit I have. Okay, shit. So, what is your name? I think it is not ethics there. It is something else. Well, my name there is Walrus. You might have seen me. Let me try to guess. Is your name SEN? Okay, shit. It's GC. Okay, and your mascot is green. And I think you use Discord with from phone. Okay, okay, okay. Now I know. That is cool. Yep. And we yesterday it was me and a bunch of people in the VC, and we had quite fun. It was like really fun. We had fun yesterday. We were talking about stuff from random stuff you might have seen in the random section in the random channel. Yeah, it was pretty cool talking to people. And now I would unfortunately have to end this stream. It has been quite long. It has been 3 hours and 40 minutes. That is quite long. And now I would like to have a rest. It's a DP question. What is your base case, bro? The base case I established using the iota function, and you are unable to see that. The base case is shit. This is the beautiful code that I wrote yesterday after reading about this on a stream, and this is the horrible code that I have written today. And my base case is being established by this iota function. Like, and but instead, this thing that I wrote yesterday, this is magnificent. Look at this. If not B, then return A. If not A, then return B. And this is recursive. I guess that is one of the things. This is recursive. This is actually cool. Shit, I gotta remove all of this. Was the code that I have written? This is very bad. Okay, after taking the string S, T, I, and take this into S and T and see out and solve takes in A and B, and if not B, return A, and if not A, return B, and otherwise return minimum. Now I have a few choices. Minimum of solve int solve A minus 1 comma B plus 1. That is one of the choices. Other is solve A comma B minus 1 plus 1, and the next one would be solve A minus 1 comma B minus 1, and and plus integer depending on S A. If it is not equal, then add 1, otherwise don't. B. C out solve S dot size T dot size 14, and a memory, a map from pair of integers to integers called memo, and if memo inside memo, if I have seen A comma B, then what is this, A comma B, then return memo A comma B, else don't just return this, and this equals this thing, and memo A comma B equals res, and return res. Shit. If not A, then return A. If not B, then return A. If not A, then return B. And memo, if memo AB is there, then return memo AB. Yep. I remove this part. Okay, memo is not the raw. -1, -1, -1, -1 because I'm indexing it. Why do I say 1? I think memo is no, memo is useful here. Memo is useful. If SA is not equal to B, then this becomes 1. Shit. It just doesn't work. Yep. Yo, it is working. That is cool. And shit. Okay. Yep. This would be the end of today's stream. And thank you for being here. This was a struggle. I was unable to do a lot of questions today. This was bad. Anyways,